Hey, welcome back to Math with Patrick. Today's August 9th, and we're solving problem number 221 from the Daily Epsilon calendar. And today, we're trying to figure out the number of two-digit primes where the number with digits reversed is still prime. And apparently there are 9 of them. The answer for these problems should always match today's date. So let's try to figure it out and find these primes. So here I wrote kind of like an array of numbers, all the two-digit numbers. You can see that I'm counting up by ones here, and I kind of skipped a few until I hit 19. And then I started my row of 20s here, and you can assume that we're going to count up to 29, and then you go 30, and so on and so forth until we reach 90, and then 99, and I can stop there because 100 is now a three-digit number. And we need to figure out which ones of these are primes and also are still prime when we reverse the digits. So, I already found one of them here. 11 is the first prime in our list, and when we swap our digits, we still get 11, so that's cool. And also 13 is going to be here too, I think, because if we swap the digits, we're going to get 31. Two things that I want to think about right now. I want to make sure that my counting is methodical, so I'm not like skipping over things or I'm not double counting things, because if I do this kind of without being careful of my counting techniques, if I come across the number 31, which is prime, I don't want to circle it because, or maybe do I? Find a count of two-digit primes where the number with digits reversed is still prime. I think I actually do want 31 here because it does count as a prime, and when I flip it, I get 13. And according to the prompt today, I actually think I do want both. So what's cool is that once I find some of these primes whose digits reverse and I still get a prime, I found two at the same time. Although I guess for the 11, I just found just the one. I also want to think about where I don't need to look. Like all of these multiples of 10, I don't need to look here because any multiple of 10, I guess, is just composite or not prime. And then I don't need to look at the 12s because those are all even. And so all of like the even columns I wouldn't need to look at. So anything like 14, 16, 18, I won't need to look at those columns. And I could kind of express it like that because here's where 14, 16, and 18 would be. Let's fill in the gaps. This would be 15, and this will be 17. Anything in this column with a 15, I also don't need to consider because anything that ends in 5, besides 5 itself, is going to be composite. And then this number right here, that would be 25, another composite number. So all of these I could just ignore. 17 happens to be another prime. I'll circle that one. And I do think that 71 is another prime. And so I guess the 71 row would be right here-ish. So I guess kind of even before I've started this methodical approach, I'm already finding a lot of my answers just kind of by happenstance. We also need this to be true when we reverse the digits. So because I crossed out like 18 right here, I could also cross out 81. And so I can imagine that this row right here with all of these 80s, I can totally cross out. Even if I found a prime in this row, I think like 89 is, I believe, a prime number. Because I know that when I flip the digits, 8 now is in the ones place. That makes an even number. And any even number besides 2 is not going to be prime. So I don't need to look anywhere in the 80s. And I don't need to look anywhere in the 60s, nor the 40s, nor the 20s. So that kind of cuts down my search a little bit. Maybe let's write the rest of the numbers here. So I had 1, 2, 3, 4 possible numbers that start with 1. 19 is prime, although 91 isn't. 91 is the same as 7 times 13. I think in a previous video I accidentally called 91 prime, but I learned my lesson. So even though 19 itself is prime, when I reverse the digits, I don't get a prime number. Skipping the 20s, moving on to the 30s, we get 31, 33, we can skip 35, 37, and then 39. Skipping the 40s, now we're in the 50s, we get 51, 53, 55, 59. And then we get to skip the 60s, and then now we're in the 70s, and we can do 71, 73, don't need to do 75, 77, 79, and then finally in the 90s we have 91, 93, and then 97. So hopefully we're going to circle, looks like 4 more primes in here because we've already found 4 of them. So I'm hoping that, we already have found 5 of them. So 4 of these should work. 33 is composite. That's 3 times 11. 39 is another multiple of 3. 93 is another multiple of 3. So those don't work. 55 is 5 times 11. That doesn't work. 77 is 7 times 11. That doesn't work. And then I just realized that I could even cross off this entire row, because if we flip any of these numbers, 5 is going to be in the ones digit. And then so anything that ended in a 5 here, I already crossed out, so I should have crossed that one out as well. So it leaves us with 1, 2, 3, 4, 5 more numbers. Oh, and then 99, that's 9 times 11. And so I can cross 99 out as well. And the 91, I should have already crossed out because I already considered it when I looked at the 19. So I'm hoping that 1, 2, 3, 4 more numbers are primes. And if you try the computation on your own, you could try dividing these numbers by other numbers that are smaller than them. The largest prime that you'd really need to check is actually only 7 for these ones. There's a little divisibility trick where you only need to use the primes 2, 3, 5, and 7 to check for primality until you get to the number 121. That's when the 11 becomes important. So if I'm checking numbers below 120, I only need to check the primes 2, 3, 5, and 7. So you could run through this list and try dividing, 37 by these numbers. You could try dividing 73, 97, or 79, and none of those will return whole numbers for you. And that's going to be enough to prove that those last 4 numbers are indeed prime. So turns out we do get 9 for today. And we get this kind of interesting pattern of primes in our grid. And here are our reversible primes. So thanks for watching. Hope you enjoyed, and I'll see you tomorrow. Okay, bye-bye.